Alright guys, this is your last lesson of the week, and I'll be perfectly honest, you don't have a lot going on next week, so you're pretty close to being done with math for the entire year. And today we're doing something kind of fun. We're talking about two-dimensional shapes, which is something you've learned about in the past, but we're going to use some newer vocab terms for you today. So make sure your SAB is open to 8-16, and the words that we're going to talk about are open, closed, polygon, and then the two big ones are concave and convex. So we're just going to kind of briefly talk about those. So basically, in your two-dimensional shapes, they're telling you that they can be made up of line segments or curves or both. So in order to have a two-dimensional shape, it can be line segments, which are very strict, like a line, or it can be really curved lines like that, or it can be a little mixture of both. That makes me want to eat watermelon. And then it says a two-dimensional shape can be open or closed. So since this is two-dimensional, you can have a shape that's open or closed. Now this is just simply talking to you about shapes. But a polygon is a closed two-dimensional shape, but it has to have line segments and they cannot cross over each other. So for example, this right here could be a polygon because it's got all line segments and they're not crossing over each other. But this could not be considered a polygon, and this could not be considered a polygon because they are not made from all line segments. This one also could not be considered a polygon, and this one couldn't be considered a polygon. This one because it's not closed, and this one because it's got curves, okay? So for example, over here, they're showing you 3 examples of polygons and 3 examples of non-polygons. The reason this one's not is because it crosses over each other. This one's not because it's curved, and this one's not because it's open, okay? The last 2 words that you need to know are concave and convex. And the way that I remember these, a concave shape is one where it seems like it's kind of like caved in on itself. So, for example, if I were to draw another one, this is an example of a concave shape, and I think of it as like this looks like it sort of caved into the middle. Whereas this is an example of a convex shape because it's not sort of falling in on itself. So let's read about concave versus convex. It says a polygon is concave if you can connect 2 points inside the polygon with a line that passes outside the polygon. Here's what they mean by that. If I were to choose 2 random spots on here and I were to try to connect those 2, I have to go outside of the shape in order to connect those 2 together, so we call that concave. A convex polygon has no way to draw 2 lines where you will then go outside of your shape, and so that means then that it's convex. I think of it like this. If it's caved in, we call it concave. If there's no spot that looks like it's caved in, it's probably convex. Okay? So, let's look at our SAB page. It wants us to label whether or not something is a polygon. We'll call it a P for polygon, and then we'll do NP for not a polygon, okay? And then we would also have to tell us why it doesn't fit the definition. So number 1 is not a polygon, and hopefully you can see why. That's because it's not closed. And then for number 2, that is definitely a polygon. In fact, we learned about that the other day. That's a quadrilateral we call a parallelogram. Letter 3, I see all line segments. I see that it is closed, and I see that it is, you know, more than 2 lines. So I would say that yes, that is a polygon. Number 4 is not a polygon, and the way I know that is because your lines cross. So we'll say not a polygon because our lines cross. For number 5, this is also not a polygon because this is not a line segment. So you're missing line segments there. And then number 6, let's see, I see all line segments. That's a closed shape, so I would indeed call that a polygon. Now, you have in your journal these little attribute cards and two-dimensional shape cards. If you wanted to do this for your assignment today, that's totally fine. Basically, what it's asking you to do is to match together the attributes. So, for example, something like this shape right here, you could tell me that it is concave, so that could work there. Or you could also tell me that it is a polygon, that would work. You could tell me that it has straight sides. Let's see. I don't see any parallel sides. It does have symmetry, so you could tell me that it has a line of symmetry. It looks like it's got two congruent sides. These look congruent. And then it definitely has an angle greater than 180. So basically you could just tell me all the attributes that match one of your cards. Again, this is optional to show me your work. You don't have to do that though. But let's go ahead and move on to this part of your lesson. So it's reminding you of some names that you probably haven't thought about for a little while, but hopefully are still back there in your brain somewhere. So it says polygons are named by the number of sides they have. And here are some common ones that you should already know. Triangle and quadrilateral are a duh. Triangle has 3 sides, quadrilateral has 4. And then we have a pentagon, a hexagon, and an octagon. And there's some pretty easy ways to remember these. Penta actually means 5, like a star is called a pentagram because it's got 5 sides to it. But I think of penta because there are 1, 2, 3, 4, 5 letters in penta, and so there are 5 sides. The other big one, though, is if you've ever seen a picture of the Pentagon. The Pentagon is actually a pentagon shape, so that's why they call it the Pentagon. Okay, so anyway, pentagon has 5 sides. It's kind of like home plate. A hexagon has 6 sides, and hex and 6 kind of sound the same. And then octagon, obviously you're going to think of an octopus, and you already know that an octopus has 8 sides. So those are ways to remember all those. So again, it says polygons in which all sides are congruent and all angles are congruent are called regular polygons. The octagon above is a is a regular octagon. Let me tell you what that means. I don't know why my printer is printing right now. But anyway, a polygon in which all sides are the same. Well, these two right here don't have any of the same sides. This one clearly doesn't have any of the same sides. This clearly doesn't have any matching same sides. But this one here also doesn't have any matching same sides. But if you were to take out a ruler and measure all 8 sides of your octagon, and all 8 sides were the exact same length, that is why we call this a regular polygon. Okay, so this is just simply called a polygon, 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 and this one would be called a regular polygon because all the sides are the same. So let's put that a little bit to use here. Number 7 and 8 want you to name the polygon and then circle all the things that describe it. So for example, on number 7, we know it's a triangle. That's easy enough. And I've given you more specific names for triangle, but for today, this is fine. Although if you're wondering, it's technically an equilateral acute triangle, but that's fine. Okay, so triangle is fine. And then it wants to know if it's regular or not regular, and if it's concave or convex. Remember, concave means it's caved in on itself. Convex means it hasn't. Vex means no. So are all of my sides the same, or are all of my sides not the same? Well, these little lines tell me that all of my sides are exactly the same. So that would be regular. And then it does not cave in on itself, so we would call this convex. Let's move over here to number 8. I've got these 2 sides are the same length, and these 2 sides are the same length, and this side matches none of them. So all 5, let's see, 1, 2, 3, 4, 5. Yeah, all 5 sides would have to be the same. 5-sided shape, by the way. I got ahead of myself. It's called a pentagon. But not all of them are the same. So this is a not regular pentagon. And this one is concave. If I were to draw my line here or my dot here and try to connect those 2 together, I do leave my shape. And so because of that, we call this cave. Plus it kind of looks like it caved in on itself. Let's look at number 9. 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8-sided shape we call an octagon. And my tick marks are helping me here. These 2 sides are the same length and these 2 sides are the same length, but they are not the same as these sides. So even though we've got a lot of similarity, it is not technically a regular octagon, I should say. So it is a not regular octagon. And then it doesn't have any sides that are caving in on itself, so because of that, we call that convex. And then finally we have a 6-sided shape. 1, 2, 3, 4, 5, 6. So that is a hexagon. And then regular or not regular, well, I see only one shape of tick marks and they're all the same. So that would be a regular. And there's nothing that caved in on itself, so we would call that convex. And then just to finish it out today, it just wants us to write 2 true or false statements here. It says a square is a regular quadrilateral. Okay, well, think about this. Quadrilateral is a shape that has 4 sides. A regular quadrilateral would mean that all 4 sides have to be the same length. So I would say that that's indeed true. Because even if you drew it as a rhombus, that still technically could be a square. Okay, and then number 12 says it is possible to draw a concave triangle. Well, remember, a triangle means that you have to, or sorry, concave means that 2 of your sides have to be dipping in on each other. But if I were to connect this to make it a triangle, well, I've just gotten rid of the concave part, so this one's actually false. The only way to do that is if you somehow curved it, but then that wouldn't be a polygon. That would just be a Pac-Man, so that wouldn't work. All right, guys, your job today, your SAB is out because we just did all those pages together. You could totally do homework and remembering. In fact, I'd love that. Otherwise, there's a bunch of options for IXL, so you could try those as well. Log into Zoom if you need some help.